Okay, have you ever wished you could just hand a powerful AI a stack of your company's private documents, or maybe your personal notes, and poof, it's an instant expert on your stuff? Well, today, that's exactly what we're going to do. We're building a custom AI from the ground up using a really cool technique called Retrieval-Augmented Generation, or RAG for short. So yeah, let's get right into it.
All right, so here's the game plan. We'll kick things off with what RAG is and why it's such a superpower. Then, we'll get our hands dirty building the two main parts, the retriever and the reader. After that, we'll snap it all together and see it work. And finally, we'll talk about how you can take this thing to the next level.
So let's start with the big question, right? How do you take a generic AI, one of these super powerful large language models, and make it an expert on your specific data? I mean, these models are amazing, but they're generalists. They have no idea what's in your project docs or last quarter's sales reports. They're basically frozen in time. So how do we fix that? Well, the answer is RAG. It's the technique that lets us give our AI a brand new brain, one that's built entirely from our own custom knowledge. So what is retrieval-augmented generation, exactly? The easiest way to think about it is like a bridge. On one side, you have the powerful creative language model. On the other, you have your private knowledge base. RAG connects the two. It lets the AI reach into your documents, pull out the relevant facts, and then use those facts to give you an answer that's grounded in your reality, not just the generic stuff it was trained on. Okay, that sounds cool in theory, but how does it actually work under the hood? Let's pull up the blueprint for our build. The whole process is actually super logical when you break it down. It all starts when you, the user, ask a question. Then, the first part of our system, the retriever, kicks in. Think of it like a super smart search engine for your documents. It finds the most relevant little snippets of text. Those snippets get passed along with your original question to the reader, and that's our large language model. The reader then looks at the evidence it was given and writes a custom, fact-based answer. It's that simple.
Okay, let's start our build. First up is part 1, the retriever. This is the foundation of our whole system. It's all about getting our knowledge base prepped and ready for a super fast search.
You know, we can't just throw a 500-page PDF at the AI and hope for the best. It doesn't work that way. The very first thing we have to do is break our documents down into smaller, more focused snippets. We call these chunks. Getting this right is absolutely crucial. If the chunks are too small, you lose all the important context. But if they're too big, the key information gets buried in a sea of noise. It's a bit of a Goldilocks problem. And this is a super common mistake people make. Let's say you just split your documents by character count. Look what happens. A huge number of your chunks end up being bigger than the model's context window, in this case, 512 tokens. Now, a token is basically a word or a piece of word. It's how the model reads. So if your chunk is too long, the model literally just stops reading. It truncates it, and you lose all that valuable information at the end. It's a total waste. But check this out. The solution is actually pretty simple. Instead of splitting by characters, we split by tokens. We measure it the same way the model does. And just like that, problem solved. Now, 0 of our chunks are too big. Every single piece of information we've prepared is perfectly sized to be fully understood by the AI. That's a huge win. All right, so our data is perfectly prepared. It's all chopped up into these nice, neat chunks. But now we have a new problem, right? We could have thousands, maybe even millions of these chunks. So how on earth does the system find the exact handful that are relevant to my question and do it almost instantly? This is where things get really, really cool. It's kind of like magic. We take every single one of those chunks and we convert it into a list of numbers. It's called an embedding. And this embedding represents the chunk's meaning. The best way to picture it is like a coordinate on a giant map of ideas. Then, when you ask a question, we turn your question into a coordinate on that same map. All the system has to do is find the document chunks whose coordinates are closest to your question's coordinate. It's not searching for keywords, it's searching for meaning. It's a total game changer. So there we have it. We've built our super fast semantic librarian, the retriever. Now it's time for part 2, installing the brains of the operation, the reader. And that, of course, is our large language model. This right here is basically the instruction manual we give to the AI. It's called a prompt template. And you can see these little placeholders for context and question. It's super simple. The snippets our retriever found get plugged into the context section, and your original question goes into the question section. We're essentially telling the AI, here's the evidence. Now using only this evidence, answer this question. It keeps the model honest and factual. Okay, but what if we want to add an upgrade, a pro-level feature?
we can add something called a re-ranker. Think of it this way. The first retrieval step is like a quick, broad search that gets us a bunch of maybe useful documents. The re-ranker is like a second-pass expert. It takes that initial list and uses a much more powerful, and yeah, slightly slower, model to meticulously reorder everything, putting the absolute most relevant documents right at the very top. It's a quality control step that makes a huge difference in the final answer.
Okay, we've built all the individual components. The foundation is solid, the intelligence is installed. Now it's time for the fun part. Let's put it all together, fire up the engine, and see this whole system in action.
So here it is, the whole workflow from start to finish. Step 1, the retriever casts a wide net, maybe grabs 30 potentially relevant docs. Step 2, our re-ranker comes in and acts like a filter, narrowing that down to the absolute best 5. Step 3, those top 5 gems get injected right into our prompt. And finally, step 4, the LLM takes that perfectly curated evidence and generates a beautiful, high-quality answer.
All right, let's put it to the test. We'll feed it a pretty standard developer question. Let's say our user asks, so, how do you create a pipeline object? Our system has all the documentation, it has the question. Let's see what it spits out. And boom, there you go, a perfect answer. It's clear, it's concise, it's totally accurate, and it even includes code examples. This is the power of RAG. The AI doesn't just know the answer from some generic training, it can explain it step by step because it literally just read and understood our documentation. And here's the best part, the proof. The system can actually show you its work. It can cite its sources. These are the exact snippets from our documents that it used to create that answer. This is so important. It's not just making things up. It's generating an answer based on real evidence. That's a huge, huge step forward for trust and reliability in AI. So we've built a really powerful, really functional system. But, in the world of AI, you're never really done. The build is just the beginning. Now comes the process of tuning, testing, and making it even better. I absolutely love this quote from the source material. You cannot improve the model performance that you do not measure. Now, Llama 2 attributed that to Gandhi. I'm not so sure about that, but hey, whether it was Gandhi or an AI hallucination, the point is absolutely golden. You can't make something better if you don't know how good it is to begin with. Evaluation is everything. So where do you start? What can you actually tune? Well, think of these as the main control knobs on your new machine. You can play with your chunking strategy, you can swap out the embedding model for a better one, you can tweak your prompt to get different kinds of answers, you can upgrade to a bigger, more powerful reader model, you can even do fancy stuff like automatically expanding the user's query. Every single one of these is a lever you can pull to get better performance. And that's a wrap on our build. We've taken a generic off-the-shelf AI and turned it into a highly specialized expert that's grounded in our own private data. So now that you have the blueprint, the real question is, what are you going to teach your AI first?